Good morning. This is your Stat Sensei, Mr. Spensei, and this is a warm-up for a hypothesis test, and this is the Want Some Candy. So a candy machine is supposed to fill bags of candy with an average of 19.2 ounces. So this is what's supposed to be happening. So that sounds like that's my population mean. And by the way, this is in your note spiral, so you can do this in your note spiral. The machine has a standard deviation of 0.1. So they're telling us this population standard deviation is 0.1. A random sample, that's important, of 32. So N is 32 bags out of a batch of 5,000. So we have a population of 5,000 was selected and a sample mean or an X bar of 19.25 ounces was calculated. Test to determine whether or not the bags is different. That's interesting. Different, because different means it didn't give a direction, so that means not equal to. So it says write the hypothesis and define the parameter, then write the conditions. So HO, well, they're claiming that it's 19.2, so mu is 19.2. The alternative is mu does not equal 19.2. All right. Now we need to define our parameter. What is mu? Well, let mu equal the true population mean. And we keep writing this because it's the same thing over and over again for the amount of candy. Now, technically, it's the amount of candy in the bag. And it's really the candy weight. But for the amount of candy, for the candy weight, all right, you know what? I'm going to scratch that out and put for the candy weight, although I would accept the other. Because that's what we really care about. All right, but amount of candy was fine. First condition, random sample. Is it? Well, let's write that. Let's find out. Let's look back. Oh, it says a random sample. So random sample of 32. And that was given to us. The next one, the N is less than 10%. Well, in this case, our sample size was 32, so we always multiply it by 10. So 32 times 10 is our population size is 5,000, so this is less than 5,000. Oh, 32 times 10 equals 320, which is less than 5,000. So N is less than 10% of the population, and I'm just going to abbreviate it POP because I'm running out of room. And I still have one more condition, the normality condition. Well, they didn't tell me it was normal, so I need to check the sample size. Well, in this case, our sample size is 32, which is greater than or equal to 30. So we can say it's normal by central limit theorem or normal by CLT, because I'm not going to write out central limit theorem. Normal by central limit theorem. All right, that's the warm-up. Appreciate you watching. I hope it helped. And once again, this is in your spiral, and I look forward to seeing you on the next one. Thank you.